Let's finish this up. F of x equals 2x plus 3 cubed. Let g be the inverse function. Given that, what is the value of the inverse at 1? So my favorite thing to do is to say that if they're inverses, then f of g of x equals x. And if I derive this, I get f prime of g of x times g prime of x with my chain rule equals 1. And if I divide this over, I get my formula for inverses, 1 over f prime of g of x. So if I want g prime of 1, I want 1 over f prime of g of 1. And this is always the one that we've got to kind of search out. Sometimes we've got to solve for it. What is g of 1? I don't even know what g is. Conveniently, I know that f of 0 is 1. So then I know that g of 1 is 0 because they're inverses. So g of 1 is 0, so I need f prime of 0, so I should find what f prime is. 3 2x plus 1 squared times 2 at 0 would be 1 squared times 3 times 2 would be 6, 1 over 6. 21, horizontal asymptote. I like talking about this problem. It's a good review problem. Horizontal asymptotes are limit as x goes to infinity. And from pre-calc, that matters for degrees. If it's bigger on the top, it goes to infinity. If it's bigger on the bottom, it's 0. And if the degrees match, it's the ratio. So this guy is our special sine one. That's not going to work. This guy is a line. That doesn't have a horizontal asymptote. This one has a vertical asymptote at x equals 5. And its horizontal asymptote, because the degree of the denominator is bigger, would be 0. This one they do match, so we can divide. 5x divided by the opposite of x is negative 5. And this one they match. 20x squared divided by 4x squared would be 5. So there it is. 22. Let f be the function defined by f of x equals natural log of x over x. What is the absolute minimum? To find minimums, we set derivatives equal to, maximums. To find maximums, we set derivatives equal to 0. So when I want the derivative of this, I want the quotient rule, low d high minus high d low over low squared. Find when that is equal to 0. I've got 1 minus the natural log of x over x squared equal to 0. I love these problems because this could never be equal to 0. So this is the only thing that can be equal to 0. 1 minus natural log x equals 0. Subtract the 1, divide by the negative. Natural log of x equals 1. E to the 1 equals x. Can we check that to be a maximum? At e, let's check something like 0. Nah, it can't be 0. How about something just a little bigger? That's something a little bigger than 0 is going to be very small here. 1 minus a very small is going to be positive. And then something bigger is going to be a bigger number than e. So 1 minus a bigger number is a negative, increasing and decreasing, so we do have a maximum. When I put an e in here, the natural log of e over e, that is 1 over e. There it is. We've got a population with a differential equation describing linear growth. Linear growth looks like this. It has a constant slope. The only one of these that has a constant slope is this guy right here. So using that, what kind of growth would this one have? It'd have quadratic growth, cubic growth. This one, we would actually divide the p over. That would have exponential or natural growth. And then that one would be another exponential growth as well. Good. Looking for a critical point at x equals 2/3 for this function. Critical points occur when the derivative equals 0. So let's find the derivative. X squared times e to the kx. Derivative of x squared is 2x. Derivative of e to the kx is e to the kx times k. Our 2/3 bow tie says x squared times e to the kx times k plus 2x e to the kx. We want that to be equal to, so if we factor this guy, and critical points occur when it's equal to 0. Let's take out an x, take out an e to the kx. We're left with x k plus 2 equals 0. So this one's going to have a critical point at x equals 0. We don't care about that. This one's going to have a critical point at x equals -2 divided by k. That's the one we care about. Let's look. K can't be 0. So what can it be? Well, actually, we want to look at, it's kind of the same thing. K equals -2 over x. So for x to be that, it's got to be the -3. For what value of k? -2 divided by -3, x equals 2/3. Good to go. Oh, good. Solving the differential equation. Let's do it. Nothing to separate here, which is convenient. dy equals 2 sine x dx. Sweet. Y equals -2 cosine x plus c. Initial condition of y is 1 when x is pi. -2 times -1 is 2, so c equals -1. -2 cosine x minus 1. Alright, we've got a first derivative equal to the integral from 0 to x. Which of the following must be true? So let's first look at g and talk about it. If this is the derivative, what do we know about g? If I'm going from 0 to x, from 0 to 2, this guy is always going to be positive. It's going to have an area, e to the negative. That's going to be something positive in the first quadrant. So this guy is always positive, meaning g is always increasing. So we've got that a few times, but I think we can cross these guys out. So now we need to decide concave up or concave down. So what would g double prime be? E to the -x squared, which again, from 0 to 2, no matter what I put in here, is always going to be greater than 0. Negative exponents don't make negative numbers. They make reciprocals, which are still positive. Therefore, this implicitly derived equation, we want the second derivative at 3, 0. So let's derive this equation. Let's use a product rule. Derivative of this is 1 plus 2 dy dx times dy dx plus the first times derivative of the second. There's our second derivative. And this is convenient because the other side ends up being 2 minus dy dx. Well, now we can start putting things in. We can put in the 3 and the 0, but we're also going to have to put in dy dx. So we need dy dx at the point 3, 0. So if I look here, and I put in 3 and 0, and 3 and 0, I end up with 6 divided by 3. So dy dx at 3 comma 0 is 2. So now we can put them all in. Let's do it. 1 plus 2 times 2 times 2 plus 3 plus 0 times what I want equals 2 minus 2. Clean that up. 1 plus 4 is 5 times 2 is 10 plus 3 times d2y equals 0. Subtract the 10, divide by the 3. I get negative 10 thirds. There it is. All right, another position one. Position of the particle moving is given by this. What is the acceleration? Where the velocity is first equal to 0. Let's take a look. We've got a position. So velocity is going to be cosine t plus sine t, where the velocity is first equal to 0. Where is velocity equal to 0? Sine t equals negative cosine t. We know where that is. That's right here. That's at t equals 3 pi over 4. So now we need acceleration, which is negative sine t plus cosine t. If I put in 3 pi over 4, I get negative positive root 2 over 2 plus negative root 2 over 2. And that would add to negative root 2. There we go. No calculator. Done. Math it up.